Okay, good day everyone. For today's video, we're going to discuss about geometric sequence. And for our lesson objectives, at the end of this lesson, you are expected to first illustrate geometric sequence, differentiate geometric sequence from an arithmetic sequence, and determine the geometric means and nth term of a geometric sequence. So before we start, let us have a review first. Okay? Now let us determine if the given patterns illustrate an arithmetic sequence or not. If it is, identify the common difference. First, we have 3, 7, 11, 15, and 19. Now, is it arithmetic or not? Correct. That is an arithmetic sequence and the common difference is 4. Next, let us have 4, 16, 64, 256. Is it arithmetic sequence or not? Correct. This is not an arithmetic sequence because there is no common difference between the terms. Now, let us have the third one. 81, 64, 47, 30. Is it arithmetic sequence or not? Correct. That is an arithmetic sequence and the common difference is negative 17. Alright, now let us proceed with geometric sequence. So it is also known as geometric progression and it is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio or denoted as small letter r. So ano yung pagkakaiba ni geometric sequence at ni arithmetic sequence? So kung sa arithmetic sequence, para makuha yung kasunod na term, idinadagdag natin yung common difference. Dito naman, sa geometric sequence, makukuha natin ang kasunod na term kapag i-multiply natin yung ating common ratio. And, paano makukuha ang common ratio? So, let us have this activity or this example. So, given the sequence 1, 2, 4, 8, and 16. So, we can find the ratio by dividing each term by the term that precedes it. What does it mean? So, we have 1 and 2. So, to find the ratio, we have to divide 2 by 1. And that's equal to 2. Okay? Therefore, the ratio of 1 and 2 is 2. Next, 4 divided by 2, that is equal to 2. And that's equal to, 2. Then, for the next term, 8 divided by 4, that is equal to 4. Next, 16 divided by 8, that is equal to 2. Thus, this sequence is a geometric sequence and our common ratio is 2. Next, we have the sequence 5, negative 10, 20, negative 40. So negative 10 divided by 5, that is equal to negative 2. 20 divided by negative 10 is equal to negative 2. Negative 40 divided by 20 is equal to negative 2. Thus, this sequence is also a geometric sequence where common ratio is equal to negative 2. Next, given the sequence 120, 60, 30, 15. Now, let us find the ratio. So, 60 divided by 120. So, we can find the ratio by finding the lowest term. So to find the lowest term, we divide both the numerator and denominator by 60. So 60 divided by 60 is equal to 1. 120 divided by 60 is equal to 2. Therefore, the common ratio is, is 1 half. Now, for the third and the second term, we have 30 divided by 60. So divide both the numerator and denominator by 30 and that's also equal to 1 half. And lastly, we have 15 divided by 30. Divide both the numerator and denominator by 15 and that's give us 1/2. Thus, this sequence is also a geometric sequence, and the common ratio is equal to 1/2. Now, for our first activity, we're going to determine if the given patterns illustrates a geometric sequence or not. If it is, identify the common ratio. First, we have 4, 16, 64, 256. Is it geometric sequence or not? Correct. This is a geometric sequence and our common ratio is 4. Next, 3, 8, 13, 18, 23. Is it geometric sequence or not? Correct. This is not a geometric sequence. Rather, this is an arithmetic sequence because there is a common difference here, which is 5. Now, let us have the third one. Negative 20, 10, negative 5, and 5 over 2. Is it a geometric sequence or not? Correct. This is a geometric sequence and the common ratio is negative 1/2. Alright. Now, how about if you are asked to find the missing term in the given geometric sequence? Let us have the first one. 3, 12, 48. Now, you can identify the missing term by identifying first the common ratio. So, ano kaya ang common ratio natin sa number 1? Yes, that is equal to 4. So, therefore, we can find the fourth term by multiplying 48 by 4. And 48 times 4 is 192. 192 times 4 is 768. Okay, now let us have the next one. Okay, so what do you think is the common ratio of this sequence? Correct, that is equal to 2 because 40 divided by 20 is 2. Now we can find the second term by multiplying 5 and 2. So 5 times 2 is 10, times 2 is 20, times 2 is 40, times 2 is 80, times 2 is 160. Third, 27, 9, and then we have 2 missing terms and then 1/3. Now, how do we find the common ratio here? So what is our common ratio? Yes, the common ratio is 1/3. So we have 9 divided by 27 and the lowest term is 1/3. Now, so to find the third term, we multiply 9 to the numerator. So 9 times 1 is 9 and then divided by the denominator which is 3. So 9 divided by 3 is equal to 3. Then next, 3 times 1 here is 3 divided by 3, that is equal to 1. And 1 times 1/3 is 1/3. Now for the next activity, so we're going to insert 3 terms between 2 and 32 of a geometric sequence. Now, we call the terms which is being inserted in between the two given terms a geometric mean. So, ang tawag natin dun sa inilalagay natin, yung ilalagay natin tatlo dyan, is the geometric mean. Now, how do we find the geometric mean? So, we're going to use the formula a sub n is equal to a sub 1 times r raised to n minus 1. So, a sub n is the nth term or the last term in the given sequence. And then, a sub 1 is the first term, r is the common ratio, n is the number of terms. Now, to identify the number of terms, we have to write down first the sequence. So, the first term is 2, and then we are going to insert 3 terms in between 2 and 32. So, our a sub 1 is 2. The missing terms are second term or a sub 2, third term or a sub 3, fourth term or a sub 4, and the last term here we have a sub 5, which is 32. Now, a sub 5 will replace a sub n in the given formula. And for a sub 1, we have this. And n, so how many terms are there? We have 1, 2, 3, 4, and 5. So therefore, n is 5. So what is missing in the formula? Correct. So we don't know the value of the common ratio. So therefore, we have to find first the common ratio. So to find our common ratio, we can apply this formula, then substitute the given terms. So a sub n will be replaced by 32, a sub 1 will be replaced by 2, and n is 5 minus 1. And 5 minus 1 is equal to 4. Now, using the multiplication property of equality, we're going to multiply both sides by 1/2 or divide by 2. So we multiply 32 by 1/2, the same as 2. Now 32 times 1/2 is the same as 16. And 2 times 1/2 is equal to 1, and that gives us r raised to 4. So next step is to find the fourth root of each of both sides of the equation, because our exponent here is 4. So you can use scientific calculator to solve for this, but this one is a bit easy, because we know that the fourth root of 16 is either positive or negative 2. Now, since we have two possible answers for the common ratio, then we can have two sets or two answers for this question. So let us use first r is equal to 2. So if r is equal to 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. And the other sequence will be using r is equal to negative 2. So 2 times negative 2 is negative 4, times negative 2 is positive 8, times negative 2, that is equal to 16. Okay, now how about this example? We are going to insert 4 terms between 3 and 96. So our n, or the number of terms, is 6. We have 1, 2, 3, 4, 5, and 6. For a sub 6 or a sub n, we have 96. And the first term is 3. So the missing is, again, the common ratio. So applying the formula, a sub n is 96, then a sub 1 is 3, then r raised to n is 6 minus 1, and 6 minus 1 is equal to 5. And to remove 3 here, we divide both sides by 3, or multiply both sides by 1/3. So 96 divided by 3 is equal to 32, and 3 divided by 3 is 1. Now to find the value of r, since the exponent is 5, we have to get the fifth root of both sides of the equation, and the fifth root of 32 is equal to 2. Therefore, our common ratio is equal to 2. Now, since we already have the common ratio, we can now identify the missing terms. For the geometric means, we have 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. Now, how about if we're going to find the nth term of a geometric sequence? For example, if you are asked to find the 10th term of the geometric sequence 1, 4, 16, and 64, so we're looking for a sub 10, right? And our n, of course, is 10. A sub 1 is 1, and our common ratio is 4. Now we're looking for a sub 10. So using the same formula, we have a sub 1 will be replaced by 1, then r will be replaced by 4, n is 10, so from here 10 minus 1, and 10 minus 1 is equal to 9. So again, you can use your calculator to find the value of 4 raised to 9. So 4 raised to 9 is the same as you multiply 4 9 times by itself, not 4 times 9. Okay. Now 4 raised to 9 is equal to 262,144 times 1, that is equal to 262,144. Okay, let us have another example. find the nth term of a geometric sequence. So here, we're going to identify the 8th term of the sequence 3, negative 6, 12, negative 24. So we're looking for a sub 8. And n, of course, 8. The first term is 3. How about the common ratio? Correct. Our common ratio is negative 2. Now, applying the formula, we have a sub 1 is 3, common ratio is negative 2, raised to 8 minus 1. 8 minus 1 is 7. Negative 2 raised to 7 is negative 128 times 3, that is equal to negative 384. Okay, sana nakuha nyo yung mga examples natin, no? Now, let us have this one. How about finding the sum of the first n term of the geometric sequence? So we have to consider this condition. The first one is when r, or the common ratio, is not equal to 1. So pwede natin gamitin itong dalawang formula na to. Dito sa una, kapag ang given ay first term, alam din natin ang common ratio at alam natin kung ilan yung n, or the number of terms. Ngayon, kung hindi natin alam yung number of terms, diba? So, we can use actually this formula, the first term, a sub n, yung last term ng sequence, and the common ratio. So, depende sa given. Titingnan nyo kung ano yung given. So, kung alin dito sa dalawa ang pwede natin gamitin. And another one, kapag ang r natin ay equal sa 1. So, hindi nyo na kailangang gamitin pa itong mahabang formula. When r is equal to 1, you simply get the product of n, or the number of terms, and the first term. Now, here are another condition. If r is equal to negative 1, so how do we find the sum of the first n terms? So, if n is even, then the sum is 0. Okay? If n is odd, then the sum is the same as the first term. So let's take a look with this activity. Now, find the sum of the first 10 terms of the geometric sequence 1, 4, 16, and 64. Now, we're going to use the formula. So a sub 1 here is 1, right? R, so we can get r by dividing 4 and 1, 16 and 4, and that is equal to 4. And so nakalagay naman sa problem, first 10 terms. Therefore, the n, the value of n is 10. So we apply those values. We have this. Then, ito muna isi-solve natin. 4 raised to 10. That is equal to 1,048,576. And then, ibabawas natin ito sa 1. And that gives us negative 1,048,575. And then yung nasa baba natin, 1 minus 4, that is equal to negative 3. Then multiply natin. So negative 1,048,575 divided by 3. So that's equal to positive na, ha? Kasi negative times negative is positive. 349,525. Now, if you would like to check your answer, you can actually list down the 10 terms. Okay? So, yan yung 10, di ba? Kapag ini-add natin yan, that gives us the same result, which is 349,525. Okay. Now, so let us have the next problem. Find the sum of the first 15 terms of the geometric sequence 2, negative 2, 2, negative 2, 2. Now, as you can observe, no, the value of r is negative 1, right? And since we're looking for the first 15 terms and 15 is odd, therefore, the sum is equal to 2. That is the same as the first term. Okay? Now, for the third one, find the sum of the first 20 terms of the geometric sequence 3, 3, 3, 3, 3. Okay, so what is our common ratio here? Correct, our common ratio is 1. So, and if the common ratio is 1, we can get the sum by multiplying n and the first term. So, we have n is 20 since we're looking for the sum of the first 20 terms. So 20 times the first term is 3, so that gives us 60. So S sub 20, or the sum of the first 20 terms of the given sequence, is 60. Okay. So now let us have this one. So is it possible for us to find the sum of to infinity of a geometric sequence? Yes, but that is not applicable to all geometric sequence. Why? So we can use actually this formula. S is equal to a sub 1, or the first term divided by 1 minus r. And this can be used if and only if the common ratio is less than 1. Kapag less than 1 lang. So the sum to infinity of a geometric sequence does not exist when r is greater than or equal to 1. Bakit? Tingnan natin. So kapag naging 1 yung r natin dito, so 1 minus 1 is 0. And 0 denominator is undefined. Hindi pwedeng maging 0 ang ating denominator. So r must not be equal to 1. Hindi pwedeng maging 1 ang r natin. Paano kung greater than 1? Okay? So let us have this one. Diba, pataas ng pataas yung ating value nung yung terms. I mean, pataas na pataas yung value ng mga terms. So, tingnan natin kapag ini-apply natin yung formula. So, a sub 1 here is 4. 1 minus common ratio here is 3. So, 1 minus 3 is negative 2. And 4 divided by negative 2 is negative 2. So, pwede ba yun? Na kapag ini-add natin ito to infinity, negative ang sagot? Mali, di ba? So, kaya hindi natin pwedeng gamitin ang sum to infinity formula when r is greater than or equal to 1. So, it does not exist for such sequence wherein the ratio is greater than or equal to 1. So, let us have example for this. So, find the sum to infinity of the geometric sequence 64, 16, 4, and 1. So, let us check first the common ratio. So, the common ratio here, 16 divided by 64 is 16 over 64, or in lowest term, that is equal to 1/4. And 1/4 is less than 1. Therefore, we can use the formula. Now, let us substitute. A sub 1 is 64 and r is equal to 1/4. Now, this is a complex fraction, right? So, we have to solve first the denominator. So, to solve for the denominator, we need to find the LCD. And LCD is 4. So, 4 times 1 is 4. Minus 4 divided by 1 is 1 times 1 is 1. So, 4 minus 1 is equal to 3 over 4. And then, we multiply the numerator by the reciprocal of the denominator. So, kinuha natin yung reciprocal nito, diba? And that is 4 over 3. So, 6 times 4 divided by 3 is equal to 8. Okay? So, therefore, the sum to infinity of the given geometric sequence is 8. How about this one? Find the sum to infinity of the geometric sequence 1/3, 1 over 9, 1 over 27, 1 over 81. So, let us identify first the common ratio. So, common ratio, 1 over 9 divided by 1/3, and that gives us 1/3. So, 1/3 is less than 1. Therefore, we can use the formula, and then we substitute. The first term is also 1/3 divided by 1 minus r is 1/3. Now, solve again the denominator. So, the LCD is 3. 3 times 1 is 3. 3 divided by 3 is 1 times 1 is 1. So, 3 minus 1 is equal to 2, and then over 3. And then we multiply the numerator, 1/3. I-multiply natin sa reciprocal ng denominator, which is 3 over 2. So, 1 times 3 is 3. 3 times 2 is 6. So, 3 over 6, or lowest term is 1/2. So, that would be all for today's lesson. So, sana may natutunan kayo. And for our reference, ang ginamit ko dito sa presentation is the Pivot 4A Calabarzon module and the grade 10 learner's material.
Okay, so thank you so much.
And I hope you enjoy the lesson. Thank you.